Bits Mesra, and is having vast experience on smart cities, and he's completed major projects on smart city. I just wanted to brief off some major projects of Professor Lokesh Tripathi. He has worked on NUIS, that is a National Urban Informative Information System project of NRSC Hyderabad, and he's also worked on DGPS experts, worked as a DGPS expert for fiber survey of Reliance Communication, and NWIA, National Wetland Inventory Assessment Project for Maharashtra, and also worked on projects of land degradation mapping of Maharashtra. So I once again welcome Professor Lokesh Tripathi on behalf of Government Polytechnic Daman. Over to you, sir.
Thank you, Ashish ji. Thank you so much. So, very good afternoon to all of you. Today, we are going to discuss on the technology of geospatial world. Am I audible?
Yes, sir. Yes, sir. Very much.
Okay.
Very much of it.
Thank you. So today we are going to discuss about the geospatial technology in smart cities, as well as what is the geospatial technology. So today I will discuss what is geospatial technology, remote sensing, what is geographical information system, and what is global positioning system. Then I will discuss on the applications of geospatial technology. Yes, where the geospatial technology is using right now. What is the smart city, and what is the role of geospatial technology in smart cities? Okay, so let's start today's session. Yes, what is the geospatial technology basically? So think about all the activity occurring throughout a landscape. How can we map that? How can we manage that? And how we will analyze that? All that is going on, and the solution will be the geospatial technology. Okay. So basically, geospatial technology, why is it important to know about it? Because it is an emerging market. It has well-paid, enhanced many jobs related to that technology with the staying power, combines computers and outdoor activities. It's in demand, and there are many more other reasons are there for the importance of geospatial technology. Basically, what is the geospatial technology? Geospatial technology is basically the combination of different techniques. That is the first is the remote sensing technique. Then second is the GIS, geographical information system. Then third one is the global positioning system. And in others, there are some other techniques also, that is database management system, as well as photogrammetry, aerial photography is well also. So these all combinedly known as the geospatial technology. Okay, so geospatial technology basically in GIS, yes, that's to web cloud, mobile applications are there. In GPS, there is navigation system is completely there. Indoor positioning system is there. Surveying method is there. And in remote sensing technique, earth observations, there are satellite remote sensing. There are satellites manufacturing, launch vehicles are there. Aerial mapping is there. UAE drone mapping is there. And as well as in scanning, there is LIDAR, light detection and imaging, laser scanning, radar is also there. So combinedly, these all are known as the geospatial technology. Okay. So let's start with the concept of remote sensing basically. So what is the remote sensing technology? Basically, remote sensing technology means there is two words, remote and sensing. Yes, remote means a distance, something sensing, identification of any objects with a distance. Okay, we can understand this concept with a very simple example. That is the how our eyes sense the different kind of objects and how we interpret that all objects. So a physical quantity, light emanates from that screen and any object which is a source of radiation. The radiated light passes over a distance and thus are remote to some extent. and it is captured by our eyes. Our eyes are as a sensor, and each eye sends a signal to a processor. Processor means your brain. Your brain will work as a processor which records the data and interprets this into information. Basically, this is the very simple concept of the remote sensing. Basically, same thing. What is the satellite remote sensing? We will let in next slide. So what is the remote sensing? Basically, remote sensing is the science and technology of acquiring information about the earth surface objects without actually being in contact with that. This is done by the sensing and recording the reflected or emitted energy, and after that it will process, analyze and applying that information. So basically this is a very simple definition of remote sensing basically. So how remote sensing is done? So very we can understand this with a very simple example, simple graphic. So the EMR, electromagnetic radiations comes through the sun, passes through the atmosphere. It interact with the different kind of objects on the earth surface. Okay, either it is water body, either it is hill, either it is building, anything else. So it will interact with the earth surface objects. Then earth objects will be somehow it is transmitted radiations, somehow it will emitted, or somehow it will reflect to the particular sensor. Sensor means the sensor is on board on the satellite. The sensor will sense these reflected electromagnetic radiation, and it will send this information to the ground receiving stations. The ground receiving station will receive this data, this database, and it will send to the data processing center. And after the processing of the data, it can be used by the users in the form of satellite image. Okay, so basically this is the funda of the remote sensing. Now very basic simple principle of remote sensing is the electromagnetic radiation is normally used as the information carrier in remote sensing. Okay, so electromagnetic waves are energy transported through space in the form of periodic disturbances of electric and magnetic power, magnetic field. Okay, so all electromagnetic waves travel through space at the same speed of light, 2.9979. This is the figure, this is the speed of light, actually commonly known as the speed of light. Okay, and electromagnetic wave is characterized by a frequency and a wavelength. Okay, so this is the simple principle of the remote sensing. Now the components of an ideal remote sensing system. Some components are, basic components are there for an ideal remote sensing system. The first one is a uniform energy source will be there, should be there. Uniform energy should be there, because without energy, without light, remote sensing cannot be possible. Okay, so a uniform energy source should be there. A non-interfering atmosphere should be there. Yes, we know that there are many particles in the atmosphere which will be interfere to the signals, to the EMR, electromagnetic radiation. So a non-interfering atmosphere should be there. A series of unique energy matter interactions at Earth surface. Yes, whenever EMR comes to the Earth surface, it will interact with the different kind of energy matter interactions at Earth surface, either in the form of soil, either in the form of water body. Maybe in water body there are different kind of water body here: shallow water, deep water, dirty water. So a series of unique energy matter interactions at Earth surface should be there. A super sensor. Super sensor means satellite system is generally referred to as sensor. A sensor should be there, a good sensor should be there, which will sense the electromagnetic radiations. A real-time data processing and supply system. Yes, there should be a data processing center which will process the data, and supply system is there, should be there. And multiple data users. Yes, definitely this technology will get success whenever the multiple data users will be there. So these are the basic components of an ideal remote sensing system. Now some terms used in remote sensing basically. So there are some terms generally used in remote sensing. Number one is satellite. A satellite is a platform that enables large area coverage with the help of sensor attached to it in space. And another one is sensor. What is sensor? Sensor, it is a device that receives electromagnetic radiations and converts it into a signal that can be recorded and displayed by either numerical data or by an image. Okay. Now, there are some specific purpose of the satellite. Generally, a natural satellite is what revolve around planet, move in design or orbit. And artificial satellites have some specific purpose, that is Earth surface monitoring. The satellite have purpose of Earth surface monitoring, which is called remote sensing satellites. Second one is meteorological observations are there, telecommunications are there, TV broadcasting, and last one is global positioning system. Yes, this technology also need the satellite actually. So these are the specific purpose of the satellite. Now I want to explain there are two types of satellites are there. First satellite is the called a geostationary satellite. There are two types of satellites. First one is geostationary satellite. So what is a geostationary satellite? Basically, geostationary satellites is moving around the Earth with the same speed of Earth rotation. Okay. This satellite is a it has a fixed place, because that's why it is called the geostationary. It has single stations. It moves around the Earth with the same speed of the rotation of the Earth. Okay, basically these satellites are known as the geostationary satellite, which are communicational satellite, which are weather forecasting satellites. Okay, these have 36,000 kilometer altitude from the surface. Okay, basically these all type of satellites are using in communication and meteorological applications. Now the second one is polar orbiting satellite, sun synchronous satellite. These satellites are moving around the both pole of the Earth. Polar orbit allows for lower altitude and more image resolutions. These satellites are known as the remote sensing satellite basically. These satellites take multiple passes of the Earth before returning to the same location. It has altitude of around 700 to 900 kilometer. Okay, and these satellites are generally remote sensing satellite. Okay, so these are the polar orbiting satellites. So basically there are two types of satellite. One is geostationary satellite and second one is polar orbiting satellite. Okay. Now the next concept of remote sensing is the resolution basically, because there are many kind of sensors are there which have different types of resolution. Okay, so we can understand what is the resolution. Basically the number of pixels per millimeter defines a digital image resolution. In remote sensing, the image is resolution by the size of the area covered by a pixel basically. Okay, each pixel is an image corresponds to a patch on the Earth surface. We can see this image. Okay, whenever I will see this patch of this Earth surface, we can see that it is blurred because this is the low resolution satellite. Okay, we can understand this concept in by this image also. Okay, there is an image. Okay, so you can see that in first satellite image there is a resolution of 1 meter, and you can identify many kind of objects are there. Okay, but whenever go through the same satellite image with the 10-meter resolution, it is blurred. Okay, and when we will go through the 30-meter resolution, it will also blurred in very badly. And in 250-meter, it is, you can see that yes, there is a pixel size basically. So we can understand, yes, there are a big concept of remote sensing is the resolution of satellite images. Yes, there are a lot of sensors, QuickBird, Iconos are there, and India's Cartosat data is there, which have very high resolution data. We will learn it in next slides also. Now there are three concepts. First one is in remote sensing. First one is data acquisition, data analysis, and signature. Okay. So what is data acquisition? Yes, the acquiring of data from the satellite in the form of numerical data or images. Yes. So you will receive you will find a data in the form of numerical or the image. Then we will go through the analysis, data analysis, the interpretation of the data acquired from the satellite in the categories of land features, water bodies, buildings, many more. Okay. Now, what is the signature basically? Okay. So signature basically is it is signature. You know very well what is the basic what is the signature? You know, yes, a unique identification of any person. Yes, unique ID of any person. That yes, it will be unique. So it is called signature. But I am talking about the spectral signature. And the concept of spectral signature means what? Yes, every features of the Earth surface, every feature of the Earth surface will reflect with its uniqueness. It has a spectral response of its unique. Means what? Yes, water reflection may be vary from the soil reflection. Building reflection will be vary from the wet soil. Okay, so next is vegetation reflection will be vary from any other grassland or any other objects. So every objects of the Earth surface have its unique spectral response. This is known as the spectral signature basically. Now there are two types of remote sensing is there. Number one is active remote sensing and number two is passive remote sensing. Okay, so passive remote sensing is what? Whenever the remote sensing will done in the presence of sunlight, sun rays, natural light, it is known as the passive remote sensing. Okay, do not emit radiation themselves. Okay, but in active remote sensing, it emit radiation themselves. They have their energy source on energy sources. Okay, just like for the examples, there is a lidar sensor, light detecting and ranging, as well as radar sensor, radio detecting and ranging. These are the best example of active remote sensing. Let's have a quick view on some slides. So we have talked about remote sensing. So we can see some satellite images so that we can clear our concept. Yes, how satellite images have been generated, how it is look like. So just like you can see that yes, dockyard as viewed by ICONOS, one of the sensor. Okay, now railway stations as viewed by the ICONOS, how railway station is look like in the satellite images. Bus stand as viewed by ICONOS. Yes, these are all the high resolution satellite images. Unplanned residential area viewed by ICONOS. MIG housing scheme as viewed by ICONOS. You can see that satellite image. Express highways viewed by ICONOS. Express highway, you can see that express highways are look like. Part of Lucknow as viewed by ICONOS. How Lucknow looks like. It is the satellite image. Part of Vijayawada as viewed by ICONOS. You can see that how Vijayawada will look like. Water pollution as viewed by ICONOS. ICONOS can identify water pollution as well. You can see that how water is dirty there. So hills as viewed by ICONOS. You can see that hilly area, hill terrains basically. Okay, so this was my first technology, that was the remote sensing technology in the geospatial technology. Okay, now we will go through the second one, that is the GIS, fundamentals of GIS, geographical information system basically. Okay, so basically what is GIS, geographic information system? Yes, geographic means on the Earth surface, whatever the objects are there, whenever we will go through it, we will manage a database of that particular information, particular objects in the systematic format, systematic system. This is the concept of the GIS, Geographical Information System, basically. So we live in two worlds. Okay. First one is natural world. Second one is constructed world. Okay. So in natural world, yes, there is self-regulating, and in constructed world, there is managed. Okay. Context and content. Okay. So in first concept is that seeing the whole with the patterns, different kind of patterns, linkages and trends, seeing the whole. But managing places in the sense of watershed, maybe it is communities, maybe in the neighborhoods, or maybe it is districts. Okay. So there are two concepts. So we are going through the managing places. Yes. So the solution will be the GIS, Geographical Information System. So basically, a simple definition of GIS is what? GIS is a Geographical Information System, is a computer-based information system that enables data acquisition, modeling, manipulation, analysis, presentation, and dissemination of spatially referenced data. Spatial location, usually a geographic location. Basically, what is the meaning of the spatial location? Spatial location means latitude and longitude. Basically, there is two concepts. There is one concept of spatial location. Location in the sense of latitude and longitude. So a GIS, Geographic Information System, is a computer-based system including software, hardware, people, and geographic information. So what is GIS include? GIS include software, different kind of softwares. GIS softwares are there, like ArcGIS, like ADAS Imagine, like MapInfo, like QGIS, Quantum GIS. There are a lot of softwares, GIS softwares are there, which is computer-based system including software, hardware. Yes, without hardware, there is no possible of GIS. Okay, so a GIS, what GIS can? GIS can create, edit, query, analyze, and display map information on the computer. This is the basic fundamental of GIS. Okay. Now, what is GIS again? We can understand this with a very simple format, simple ways. You can see here there is an image. Okay, so how different layers. First, we have to understand what is meaning of the layer. Okay, in the GIS, layer means what? A single information about any single object. Like I have information of the customer. I have information about the customers. Another one have information about the buildings, and another one have information about the streets. Whenever I will combine these three informations, it will create a map with the reality. Yes, and it is known as the smart map. Okay, it is known as the smart maps. So typically a GIS is used for handling maps of one kind or another. These might be represented as several different layers, where each layer holds data about a particular kind of feature. Like I have just explained you. Suppose I have created forest area. I have created a layer of forest area. Another one have created the information of the soil type, and another one have created the data of the built up area. So whenever I will combine these all three layers into a single layer, it will show us the reality where the forest area are there, where the buildings are there, and where the other things are there. Okay, so this will known as the smart map. Okay, so this image will explain you everything about the GIS. Yes, GIS will include 3D modeling, GIS will include GIS modeling, GIS will include satellite image, GIS will include aerial photography. So these all technology will link to the GIS basically. Okay, that's why this complete technology is known as the geospatial technology. Okay, so now the genesis of GIS. Yes, GIS has its root in the stimulus provided by the development of remote sensing in the late 1960s and early 1970s as a potentially cheap and effective source of Earth observations. Roger Tomlin, 1960, the father of Canada GIS, is credited with visualizing the need for computers to perform certain simple but labor-intensive tasks associated with Canada land inventory. We can understand this GIS how it is developed actually. He saw that if a map could be represented in digital form, then it would be easy to make measurements of its basic elements, specifically the areas assigned and the tedious hand measurement of area by conducting dots on transparent overlay of non-dot density. So Tomlin's cost-benefit analysis showed that computerization would be cost-effective despite the enormous cost involved and the primitive nature of the computers of the time. Okay, David Bickmore, 1934, the primary GIS innovator, has discovered that GIS stems from the benefits of automating the map production process. And Ray Boyle invented the free pencil digitizer. And by 1964, Bickmore and Boyle set up the Oxford system for high quality digital cartography. So this is the basic development of the GIS basically. Now the concept of GIS is there. What GIS will do? Suppose this is a map created in the software of GIS. Okay, so what is the role of database basically? One can see this. One can observe only that is only a map, but it's not like that. It's only it's not only map. It has the lot of database relevant to the every pixel, every place. Okay, so you can see here. I just clicked here. This yellow colors. It's showing me the database behind this. Yes, these are the database. Maharashtra, iski ID, named, typed, reasons, check, reason code, everything. Whatever you have decided which database should be there. Whatever you have attached the database with this layer, this in map, everything will be here only. Okay, so basically this is the concept of basically GIS. So Geographic Information System offers capability of integrating multi-sector, multi-level and multi-period database. GIS is a computerized database system for capture, storage, retrieval, analysis and display of spatial data. Okay, so GIS offers capabilities of integrating multi-sector, multi-level and multi-period database. GIS has the capability to integrate. It can combine the different sectors as well as different level of database, different period database. Suppose you have database of 1960 and now you have database of 2001. Yes, you can compare, you can integrate that data in a software. So it has the capability of GIS to integrate this type of data. So GIS is a computerized database system for capturing, storing, retrieval, analysis and display of spatial data. Okay, so GIS basically what GIS do? GIS just capture. First it capture the database. Suppose somewhere you have went and you just captured location of the well. Okay, so this is the database. You store this database into computer. You retrieve this data. you analyze on data, on well locations data, and you will display in the form of a map of that all spatial data. Okay, why it is word spatial? Because it is related to the location. Whenever a data will be related to the location, particular location, it will known as the spatial data. It is general purpose technology for handling geographic data in digital form and satisfying the following specific needs among others. Okay, so basically there are some basic needs, specific needs are there. Okay, so the GIS fulfill that all particular specific needs. The first one is the ability to pre-process data from large stores into a form suitable for analysis, including operations such as reformatting, change of projection, resampling, and generalizations. Okay, so GIS have the ability to pre-process the data. It have many operations. It includes many operations. Just like whenever if you want to reformat some database, you can do it. If you want to change the projection, what is projection? Basically, projection is a basic concept in GIS. Basically, yes, every map, whatever you have created, must have a particular projection because it is required for the map creations. So if you want to change, suppose you want to change geographic lat long projection to UTM projection, yes, you can do it, you can change it. If you want to resample the database, you want resampling of the any database, you can do it. You want generalization of any data, you can do it in the GIS. Basically, direct support for analysis and modeling, so that form of analysis, calibrations of models, forecasting and predictions are all handled through instructions to the GIS. So GIS is how the power of analysis and modeling. Basically, there are a lot of analysis is there, like network analysis is there, point pattern analysis are there. Okay, as well as surface analysis there. You want suppose you want a elevation model of any particular area. Suppose I need a elevation model of Bhilwara. Okay, so in the spatial analysis in GIS, I can create an elevation model to show the elevated area of the Bhilwara district. So it has the many kind of power of analysis and modeling. Okay. Now the post processing of results include such operations as reformatting, tabulation, report generation, and mapping. Yes, in the post processing, yes, the result including such operations as reformatting. If you have reformatted something, yes, in table format also, in report generation also, in map format also, you can process these all results in the following formats. Now, simplified information system overview. Okay, so simplified information system overview, you can understand this one. Okay, that planning is there. Okay, planning, there must be a planning for the particular. Then data collection must be there. You will collect the data, all the information for your particular planning. Data storage is there. Okay, you have to store that all data into computer. And manipulation and analysis is there. Yes, you will be store the data and you will mapped in a particular scales, and then you will the analysis for the storage data. Then it will give you the output products. What will the use of output product? yes, user actions will be there. User will use that output, and if your output is good, yes, user needs will there. Then again it will be planning, and again the flow chart will be same. Okay, so you can see that how a simplified information system overview is there. Okay. Now I will explain these all three words: geographic, information, and system. Okay. So what is mean of geographic? 80% of the government data collected is associated with some location in space. Geographic. Geographic means the data which is related to the location. Location means on the earth surface. Okay. And information means what? Attributes or the characteristics data, non-spatial data, can be used to symbolize and provide further insight into a given location. So, first one is geographic, location data, then attribute data, information, and the system, a seamless operation linking the information to the geography, which requires hardware, network, software, data, and operational procedures. Suppose with an example we can understand that I collect the data as the Sangam University, which is a location based. Okay, now I have collected information, characteristics of that particular location data, that how many rooms are there, how many faculties are there, how many labs are there, how many libraries are there. Okay, so these all attribute data combinedly with only a single location, and whenever I will link these all information with the hardware, I will put these all information into computer, I will connect to the network, software, data, and procedure, then it will be a systematic flow, either in the map format or in the table or graph format. Okay. So now not just software, not just for making maps. Okay. Now some ways of using GIS technology. Wherever special data analysis is needed, so where GIS technology are using a lot of much. Emergency services like fire and police, they are using this technology. Environmental monitoring and modeling, business site location delivery systems are using this. All Zomato, Domino's are using this technology. Such kind of technologies are there. Industry, transportations, communication, mining, pipelines, healthcare, utility mappings, they are using this technology, GIS technology. Government, local, state, federal, military, everywhere this technology is using. Education, research, teaching tool, administrations, education sector is also using this kind of technology, GIS technology. So GIS have a vast technology basically. GIS based on many disciplines and technologies. So there are many technologies are there, many disciplines are there which based on the GIS basically. Geography, yes, geography is based on the GIS based on geography also. GIS based on cartography also. Now it is known as digital cartography. Computer science, yes, GIS based on computer science also, mathematics also, statistics also. Remote sensing, GPS, surveying also. Telecommunications is there, internet is there, IoT is there, operation research is there, information science is there. These all disciplines and technologies are linked to the GIS basically. For the telecommunication, you can see that yes, there is a program, outreach program. There are a lot of outreach programs are there, from where students are getting a lot of information, lot of knowledges through the software EduSat satellites. There is a satellite, EduSat educational satellite, which is using this this technology. Okay. Now we will talk about the data. Again and again we are talking about the data, and I am continuously using the word spatial data. Okay. So remember definition, spatially referenced data means there are two type of data, spatial data and non-spatial data, attribute data. Okay. So I have just, spatial data means what? X, Y, Z or latitude and longitude of a whale or any location. Whenever you have latitude and longitude of any location, that is known as the spatial data. And what will be the non-spatial data? Whenever you have characteristics of any spatial data, means what? Suppose I have just repeat that example. I am talking about Sangam University. It is a spatial data. Because it is based on the location. But whenever I will talk about the how many rooms are there, how many faculties are there, these all are the attribute data basically. Okay. 2 minutes only. So spatial data, basically we will talk about the spatial data. There are two types of spatial data, raster data, vector data. Okay. So what is the raster data? What is the vector data? You can see that there is two images, data models are there. First one is the raster model, which is in a pixel format, which is in a row and column format. But vector data, which is in the format of line, point, polygon, everything is there. So it is in the geometric format. Okay. So vector data is what? A vector system usually store data as coordinates. Locations are there. For example, each uniform area is surrounding. For example, each uniform area is surrounded by a set of straight line segments called vectors. In a vector-based system, every point is recorded by a pair of x and y coordinates. Okay, latitude and longitude. Straight line segments called vector are displayed to indicate line-based data. Road, river, many things are there. The xy coordinates at the end of each vector can be digitized and stored. Most spatial features can be displayed as either it is point or line or in polygons. Okay, so these are the basically vector data. What is the raster data? A grid system stores data as a string of characteristics in which each character represents a location. Okay, I explained earlier what is raster data. Raster data must be in a pixel or in a cell or in a row and column. Each cell pixel is assigned only one value. An array of pixels form the entire entity, point, line, area and surface. The shape and size of the array determines the basic resolution. Polygons can be formed indicating areas of homogeneous characters. Simply, I will explain you both things. If you have satellite images or a scan map, it will be in pixel. Okay. Whenever any image in a pixel, it is on the raster data. And if I will draw a map, I will create any map with the help of point, line and polygon. This data will be called as the vector data. Okay. So how does a GIS work? GIS data has a specially geographic reference. This might be a reference that describes the features on the earth using. So how it will describe? Either it will use latitude or longitude. Either it will use national coordinate system, means datum. It will use datum or your coordinate system projection and everything. An address and district, a wetland identifier, a road name, everything. So this might be a reference that describes the features on the earth using. So now I have completed my second technology of geospatial technology, that is GIS. Okay, so Third one is the GPS, Global Positioning System. Okay. So global positioning system is what? Global positioning system is a worldwide radio navigation system which determines the precise location, velocity as well as time. Okay. So what is GIS? The GPS, the Global Positioning System. GPS is a satellite-based navigation system developed by and operated by the US Department of Defense. GPS is the shortened form of NowStar. Okay, NowStar GPS means it is the GPS system which of the USA GPS system is known as the NowStar, navigational satellite timing and ranging. NowStar GPS, this is an navigation system with time and ranging global positioning system. This NowStar using 24 satellites to determine the accurate three-dimensional position of the user on the earth. Okay. GPS was originally designed for military use at any time, anywhere on the surface of the earth, but soon after proposal it is made available to the civilian user also. Now there is two types of code in the GPS. Number one code is just encrypted, and second code is for civilian use. That is called the CA code, civilian code, which can be used by the civilian. So evaluations of GPS, the GPS project was proposed in 1973 to overcome. Okay, first satellite was launched in 1978, but it became fully operational with launching of 24th satellites in 1995. Advances in technology and new demands on the existing system have now lead to effort to modernize the GPS system and implement the next generation of GPS third satellites. Okay, so there are different countries which are using this GPS technology by their own. Russia, yes, Russian countries is using as GLONASS technology, GLONASS, Global Navigational Satellite System. America is using, US is using NowStar. European countries is using Galileo Positioning System. India is using now. India is now has its own GPS system that is called IRNSS, Indian Regional Navigational Satellite System, NAVIC. China have also its own GPS system. Okay. So basically, what is the GPS technology? GPS have three segments. Okay. Number one segment is space segment. What means the space segment? Yes. How many satellites have launched in space? How they are working? Okay. How they are giving the signals to their surface? Okay. How the signals are. So these all things which is related to the satellite is known as the space segment. Now the second segment is control segment, where the signals are receiving, how these signals are distributing to the users. So these all things covered by the control segment. There is a master station, there are monitor stations also, there are ground antennas also. These all things which control the all signals is known as the control segment. The third one is the user segment. User segment means what? How kind of GPS receivers are there? How GPS receivers is using? These all things are known as the user segment. User segment means what kind of GPS technologies there, GPS receivers are there. There are a lot of GPS receivers, okay, Leica and Trimble. There are a lot of types of models are there. So there are three segments of the GPS basically. Applications and future aspects: location-based service, vehicle tracking system, creating database for transport engineering, disaster monitoring system, earthquake monitoring, surveying, building special infrastructure, building transportation network, resource utilizations. So these are the applications and future aspects of the GPS basically. Now India have its two success in the field of GPS. Basically, first one I have already explained you. India have its own GPS system that is known as Indian Regional Navigational Satellite System. Okay, and it has actually 7 satellites in the space India have in IRNSS, and other one is Gagan. Gagan one is also there. India's another success, GPS aided geo augmented navigation system, jointly implemented by ISRO and Airport Authority of India. Gagan payloads operational is GSAT 8 2011, GSAT 10 2012, and GSAT 15 in 2015. So these both are the big success of India in the field of GPS, global positioning system. Now you can see that yes, Navig positioning and measuring for fishermen, boat locations, fishing zones alerts, cyclone high waves, tsunami, international border alerts. These all things are controlling by the Indian Navig positioning system, which is IRNSS, Indian Regional Navigational Satellite System. Okay. So in remote sensing, I have explained you. Now I have completed my all technologies, 3 technologies: remote sensing, GIS, and GPS, geospatial technology. Now I will explain the applications of the geospatial technologies. Okay. So I have just explained earlier. There are 2 types of satellite. Number 1 is geostationary, and number 2 is polar orbiting satellite. So INSAT is the example of geostationary satellite. So geostationary satellites are using in communication and meteorological broadcasting. These all applications are relevant to the geostationary satellite. So INSAT applications are there. INSAT satellite is using India's in television broadcasting, direct to home DTH, TV and radio networking, meteorological imaging, data collection platform, disaster warning, mobile satellite services, search and rescue operations, satellite navigations, telehealth is also there, tele-education, emergency communication. You know, ISRO has a one project on VRC, Village Resource Center is there, a big success of the India's. So yes, these all things happened through the INSAT applications, because INSAT satellites is a very vast applications in the field of communication and broadcasting and meteorological. There are some space centers and units in India. So yes, you can see that India completely covered all our India with the very space centers and units. There are 5 RRSCs are there, Regional Remote Sensing Center in India, which covered all our India, south, east, west, and center. Okay, and there is ISRO center in Bangalore also. Okay, in Ahmedabad there are Space Application Center, and in Dehradun there is IRS, Indian Institute of Remote Sensing. So yes, India covered completely with the centers and units in India. India have a big achievement, yes, accomplishments in space. 171 Sun plus missions are there. 105 satellites, remote sensing, communication, navigational, space sciences are there. 10 student satellites are also there. 75 launch vehicle missions are there. And the big achievement of India is that India have now GSLV Mark III. GSLV Mark III is a launching vehicle which is a heavy payload vehicle actually. Before that, India haven't this heavy payload vehicle, but now India have its own GSLV Mark III. It is a big achievement of India basically. So Indian space program dimensions are there: space transportation, space infrastructure, space applications, and capacity building. Okay, so space transportations are okay. PSLV, Polar Satellite Launch Vehicle; GSLV, Geostationary Satellite Launch Vehicle; reusable launch vehicles, modular launch vehicles are there. And in space infrastructure, yes, Earth observations, communication, navigation, space science, and planetary missions. These all things, space infrastructures are there. Space application. What are the applications of space? Socio-economic security, sustainable development, and synergistic applications are there. Capacity building, human resource development, technical infrastructure, international corporations are there, industry, academia, outreach. These all are included in the capacity building. India's current space assets, you can see that yes, there are communication satellites, INSAT, remote sensing satellite, ResourceSat 1, 2, Cartosat series, RISAT series, Oceanosat series, Saral, SCASAT series, HISIS, which is a hyperspectral sensor, Microsat, navigation satellites also. I have explained you earlier. IRNSS 1A, 1B, 1C, 1D. Gaganyaan payload is also there. Space science satellites is also there. MOM, Mission of Mars, and AstroSat. So these are the India's very big achievements are there. Eyes in the sky, yes. Lands and water related, there are ResourceSat satellites, ResourceSat 2, high resolution Cartosat. India have, the big thing is India have its own high resolution satellite. That is Cartosat 1 and Cartosat 2, Oceanosat 1 and Oceanosat 2, Saral, weather climate for Kalpana, INSAT, Megatropics. These satellites are there. Okay, so these are the eyes in the sky, India's. Imaging technology is also there. Yes, India have its big technologies that, yes, in the single satellites, it have three different kind of sensors are there. One is 3-tier imaging, like list 3 sensor is there, pen which have 5.8 meter resolution is there, and wide field sensor area. If you want to cover the big area, it is also there. So 3-tier imaging is also there for India's. Now you can see that Cartosat 2S image, how it is. You can see that how it is looking, looks the 3D vision, okay, as well as how it is have the high resolution. Space technology applications are there some. So socio-economic security, food, water, energy, shelter, infrastructure, information, impact assessment, coastal ecosystem, climate change impacts, urbanization, geosphere, biosphere, planning, governments, planning, monitoring, evaluation, decision support system, planning for smart cities, disaster risk reductions, preparedness, early warning, response, recovery. So these all applications are based on the space technology basically. Now temporal monitoring, land use. So through the satellite images, you can monitor the temporal database, temporal changes in the land use, how land use is used, changing day by day. You can judge by the satellite images as well as database. Crop production estimation, in that you can see that yes, you can identify the area, crop area. Okay, 8 crops and rabi pulses are there. Food grain availability and policy decision on procurement and stock management. Okay, rice, wheat, mustard, sugarcane, whatever you are just increasing in. So crop production estimations you can identify, you can calculate, estimate from the satellite images as well. Surface water dynamics. Okay, so here you can see that yes, continuously monitoring of all water bodies, either it is small, medium or big reservoirs. Okay, so you can see that how GIS mapped, this is not the vector file basically. This is the raster file, this is the vector file. When I have just digitized these all water bodies, okay, so this is the vector file. Okay, so how surface water dynamics are there through the remote sensing technology. National Drinking Water Mission project is there. Yes, so this was the big project of India which is covered and done by the geospatial technology. Forest type and biodiversity. Yes, you can judge, suppose this area you can see like this. Okay, rich biodiversity in mountainous areas, 125 vegetation types you can identify from the satellite images as well. Watershed, soil and water. Yes, so watershed management is also done by the geospatial technology. Okay, and you can see that yes, in 2009 this area was there like this, and now in 2016 this area is like that. Okay, so how watershed development area development done by the remote sensing GIS technology. Mahatma Gandhi Narega mission is also there. There is a web portal done by the geospatial technology web portal registration, state GIS nodal officer, district GIS nodal officer, GIS assets supervisor block. Okay, so this is also the Mahatma Gandhi Narega mission done by the geo portal and mobile applications for monitoring implementation of activities. Geospatial technology for AMRIT program of MOH and UA. Okay, so ATAL mission for rejuvenation and urban transformation program is also done by the geospatial technology. Data generation at 1:4,000 scale using 0.5 meter resolution satellite. Okay, so you can see that yes, how very high resolution satellite data and extracted information. Pradhan Mantri Awas Yojana housing for all. It is done by the geospatial technology. Okay, more than 45 lakhs houses, 29 states have been covered. Geotagging of beneficiary houses. Disaster management support. Yes, there are floods, forest fire, cyclone, landslide, earthquake, drought. In all disaster management support, the GIS technology, geospatial technology has been used. Cyclone prediction, roll of Indian satellites, INSAT, SCARSAT. These all satellites is just doing the job for cyclone predictions. It's a track, intensity, landfall, storm surge, everything. Kerala and Karnataka disaster 2018. Yes, it is completely measured and done by the geospatial technology in India. Kerala floods, how we responded from space. Yes, there are a lot of Bhuvan data is there, visualization of IMD weather for products, Bhuvan training. So these all data is just measured by the Bhuvan portal also. Bhuvan Geo portal is there, National Geospatial, and it has 1 meter and 2.5 meter satellite data for nation. Plans to have twice national coverage, 2D, 3D on mobile. So this is a portal, one portal which have a lot of information. If you want some data or some satellite data or some GIS data you want to use, so or you want to see, you can go through the Bhuvan portal where a lot of data is there for the users. Another one portal is India's Varis Water Resource Information System. Varis project is there. This is also the web-based GIS. Okay. 12 major info system having 108 special layers with 5 to 100 year hydrometeorological data is there. So 12 layers are there: surface water, groundwater, hydromet, water quality, snow cover glacier, inland waterways, in inter-basin transformer, hydrological extremes. These all information are there on this India Varis web GIS portal. So you can go through it. Remote sensing applications in agriculture. Now you can see this both images, where this image of January 17, 2010 and it is of 2011. In 1 year you can see the changes in the vegetation, how much changes are there. Okay, these red colors are showing the vegetation. Okay, red color are showing the vegetation basically. Identification of problematic soil. Yes, you can see that there are two images, 1975 or 1999. You can see there how waterlogged area and soil has been changed in 1975 and 99. Jaunpur area, you can see that yes, there are lot of changes in both images. You can see this in 1975, salt affected soil was around 46,000 hectare. but in 1999 there is only 28,000. So how these area have been covered through the remote sensing? Water resource, lineaments, valley fields, abandoned flood plain, dikes, folds, these all things identified through the remote sensing technology, remote sensing satellites. Okay. Glacier inventory retreat. Yes, we know that glaciers are, we have heard in many magazines and newses that yes, glaciers are retreating, but through the remote sensing technology, through the GIS technology, you can see that how the glaciers is retreating. Okay, in 1962 boundary. Am I audible?
Yes, sir. Yes, sir.
Okay, thank you. So remote sensing technology is using in glacier inventory, glacier retreating also. Yes, how many losses are there, how area is just losing, how it is retreating. You can see, you can measure through this technology, through this geospatial technology. Space applications for climate change. Yes, there are geospatial technologies also there for climate change, sustainable habitat, water mission, Himalayan ecosystem, GH, greenhouse gases assessment within, and strategic knowledge, sustainable agriculture. There are a lot of applications for climate change. So you can use this technology. Basically, this is the vast subject, vast area. So I can just show you the how this technology can be used in particular applications only. Okay. So these are the completely still now I have explained you the geospatial technologies, what is remote sensing technology, what is GIS technology, what is GPS technology, how these technology are using in different applications, different areas, different big project of India. Okay, I have explained these all things in very short. Okay, so now comes to my point, geospatial technology for smart cities. Basically, how geospatial technology is using for the smart cities basically. So yes, everyone know what is the smart city. Basically, smart city has basic infrastructure, uses smart solutions to make infrastructure and services better, and relies on area based development. So basic objective of the smart city is to provide basic infrastructure, quality of life, clean and sustainable environment, apply smart solutions, set examples to be replicated both within and outside the smart city, and catalyze the creation of similar smart cities. Smart city, the characteristics of basic smart city: uses physical infrastructure more efficiently, supporting strong and heavy economic, social, cultural development, reduce usage of environmental capital and support smart growth, promotes the use of information and communication technologies, provides high quality of data life. So basically, what is the basic infrastructure? Basic public infrastructure is built by DOT and synergizing with other missions and scheme as according to the AMRIT. Basic infrastructure include assured water and electricity supply, sanitation and solid waste management, efficient urban mobility and public transport, affordable housing, robust IT connectivity, e-governance and citizen participations, safety and security of citizens, health and education, and economic activities and livelihood opportunities. Basically, IoT, ICT, these information technology, net internet based technology will play a vast role in the smart city, in the creation of the smart city basically, because yes, definitely IT is there, and IT, whenever IT will include in the technology, in this other technologies, definitely we will success for the particular objects. City-wide smart solutions, basically. So cities may added any number of smart solutions to the area-based development to make government funds cost-effective. E-governance and citizen services, energy management, urban mobility, water management, and waste management. These points are there. So in e-governance and citizen services, public information, grievance redressal, electronic service delivery, citizen engagement, cities eye and ears, video crime monitoring, and in waste management, waste to energy and fuel, waste to compost, waste water to be treated, recycling and reduction of CND waste. In water management, smart meters and management should be there. Leakage identification, preventive maintenance, water quality monitoring, smart meters and management, renewable source of energy, energy efficient and green buildings, smart parking, intelligent traffic management, integrated multimodal transport. And in other, there must be telemedicine and teleeducation. Completely teleeducation, telemedicine means yes, we have to include the IT. Trade facilitation centers, skill development centers, and many more. So what are the smart solutions? I have explained already this one. So indicators are there. Smart cities, there are some indicators of smart city, smart people, smart economy, smart governance, smart mobility, smart environment, smart living. Okay. So these are the indicators. I will explain here these all. So smart people means level of qualification, flexibility to get more opportunities, knowledge about the policies and schemes launches by the government would be the first step of each and every individual public participations. And in smart economy, indicators like entrepreneurship, productivity, self-employment rate, GDP per person, flexibility of labor market, reliability, smart infrastructures which directly proportional to the per capita income. Okay, in smart governance, efficient government services such as the e-government portal services, e-learning project, e-passport, public participation in decision making, smart energy, smart grid, energy storage, smart meters. Smart mobility must be there. Yes, smart mobility means streamlined transportation in order to optimize traffic flow and increase connectivity. And smart environment, renewable of energy, wastewater management, provide proper sanitation to citizens. Smart living, built intelligent building management system which will be help save up to 30% of water uses, 40% of energy uses, and reduction of building maintenance cost by 10 to 30%. Smart cooling, smart heating. Okay. Now I have smart services delivery areas through ICT for urban management. Yes. So water supply, wastewater, municipal services, revenue management, solid waste management. So resource management, distributions, quality, billing, grievance handling. In solid waste management, bin and vehicle tracking system should be there. Waste collections and transfer, treatment and disposal, biometric attendance system for sanitary workers. Okay. And in revenue and management, property tax, e-procurement, accounting, personal management. And recommendations is that GIS and GPS enabled service, GPS and GPRS technologies through cell phone images are taken and stamped with the time and location, integrating various database. Okay, finally, the recommendation for the smart city is the use of the geospatial technology. Now I will come to my point, building smart cities, GIS tool and techniques. So GIS plays an important role in transforming a city into a smart city. Some techniques are there which will use in the smart city: LIDAR, light detecting and ranging, laser imaging detecting and ranging. LIDAR, also known as ALS, airborne laser scanning, is a remote sensing technology that measures distance by illuminating a target with a laser and analyzing the reflected light. While conventional GIS, topographical mapping, total station GPS, involves single data point recording. LIDAR uses cloud of data points, thereby increasing the accuracy of the data being collected. So LIDAR is very useful for urban planning in smart cities. With the help of it, an accurate topography of land can be mapped and proper designing and planning for city can be executed. It is very useful in execution of e-governance based urban planning tool like building information modeling, auto building plan approvals. In that all applications, LIDAR is the most important role in the smart city. Now, second one is GPR, ground penetrating radar, basically. So GPR has wide range applications in smart cities. It can be widely used to identify faults in underground water and power network and address them with the great accuracy with the minimum efforts and time. GPR can provide precise and reliable information about the presence, location, and depth of these utilities and other buried infrastructure for any construction work to be carried out. So second technology, which is GPR, ground penetrating radar, is useful in smart cities. Third one is BEAM, building information modeling. BEAM is an intelligent model based process that provides insights to help plan design, construct and manage buildings and infrastructures. Building information modeling, BEAM, is a new way of approaching the design and documentation of building projects. BEAM stands for building information and modeling. Building means the entire life cycle of a building is considered: design, build and operations. Information, all information about a building and its life cycle is included. Modeling, defining and simulating a building, its delivery and operation using integrated tools. Okay. So BEAM, design, build and operate. What it can do, what BEAM will do: detailed design, analysis, documentation, fabrications, construction logistics, construction 4D, 5D, operation and maintenance, renovations, everything will be completely covered through the BEAM. With the advent of the concept of smart cities, the future of the construction industry is going digital, and BEAM is the future of digitization in designing and long-term facility management. It is driven by the technology with clear process, and it is implementing change across all industries. So BEAM is another technology which is using in smart cities. How GIS is used in the planning and development of smart cities. So GIS is deployed at every stage. We can see this diagram also. Spatial planning is there. Okay, spatial planning is there. Then GIS, ICT and GIS will be combinedly used, collecting the data, processing, communicating, analyze, data driven decision making, and again it is included to the spatial planning. Okay, so these are the smart ways. Spatial planning, yes, how you will plan a spatial plan, how you will manage through the GIS. You can see this, how in a software you can see that, yes, how these smart cities operations will be done through the software. GIS ICT means underlying scalable framework with a seamless flow of data information connecting departments and stakeholders. Yes, whenever ICT will connect with the GIS, definitely it will create the best scalable framework, flow of information data, collecting digitization of geodata, spatial database, sourcing data critical to smart city management. Then processing data management in real time, maintenance of open data protocols, communicating a two-way flow of information between participants, stakeholders and citizens, real time alerts and actions in a distributed computing environment. Analysis, crunching of structured, digitized and unstructured social survey, big data for analysis in real time. You will, whenever you will include your map data and the survey data, okay, so it will create the best analysis. Data driven decision making, the always connected ecosystem, max possible real time management and decision. So another way of the use of GIS technology in smart city, there is land information system is there. Okay, so how digital cadastre, digital land registry is there. Okay, 3D information is there. How land use policy is there, land policy pooling is there, land explorations is there. So definitely there is a policy, land policies will be there, and using the 3D information technology. So result will be what? Easy visualization of the data, accurate analysis, and better plan. Suppose there will be a problem, there will be a solution. So problem is there is a mixed land use, residential, agriculture, industrial, open place, water body, public place. These all are the mixed land place. The solution is what? You have to create a land information system plus your land policies. Again, problem is that data about land, location, elevation, extent, land use, land cover, type, public. The solution is what? Yes, surveying is there. Topographical cadastral survey. Topographical means topo sheet. Topo sheet is there. Cadastral survey is there. Field survey, GPS is there. Total station is there. Photogrammetry, aerial photography is there. Radar is there. Remote sensing, satellite images are. So problem is that, but the solution is your geospatial technology. Geospatial technology is all time there. Site selection. Suppose you have to select. You are confusing for site selections for street lights, information boards, new constructions, park, building, road. So network design, road, pipelines, electric lines, internet cables, sewerage system. So the solution is what? Geographic information system, GIS. You have to go through the GIS. Definitely you will store, visualize, analyze, make decision from disseminate data and information. So how? ArcGIS, QGIS, Grass GIS, these are a lot of softwares are there. Okay? And in which software? Yes, there are software, hardware, people are there, methods are there. These are the 5 parts of GIS. Okay? And when it will come to the analysis part, there will be buffering, intersection, any criteria. Buffering means what? Suppose you are creating a road, or suppose you are just going through the electric line, and you want an offset. You want an offset of both sides, 1 meter buffering you want. Then in GIS it is very easy. I mean, but only you have to give your how many buffering you want, how many offsets you want. It will create directly. So GIS analysis is there. It's a big things. Number of buildings lying at 30 meter far from highway. Suppose we have to find out, yes, in between 30 meter from highway, how many buildings are there. You go through the buffering. Yes, it will calculate the number of buildings are, how many number of buildings are there. So this is the geospatial technology basically. 3D models in GIS, other software also there. Building, road, parks, stations, hills. E-governance plus public participations. For that solution, web maps are there. Google Map, like communicative plans are there made by government to citizens using maps. So particularly maps are the best way for the many kind of problems related to the land information system. Real-time location-based service. Suppose you want to create real-time location-based service, traffic, parking, sport updates, garbage collection updates, Internet of Things, IoT, accident, crime control, disaster. Yes, solution is GIS, GPS, crowdsourcing, web maps. The geospatial contribution to digital twin. Beam data is there, 3D map is there, data infrastructure is there. Spatial data, topographic base map, land records, utility management, telecommunication, environmental, census, urban and regional planning, disaster management, healthcare, education, logistics. Is all sector of human activities. So evolution of digital map from 2D to 3D. This is the 3D map. 3D map. What is the use of 3D map? Yes, for visualization, unit-based indoor applications, stage 2, and 3D map for city modeling. If you want to modeling the city, if you want to unit-based indoor applications you want, and or for visualization. For these all things, 3D map is there. Generation of 3D map, digital map involves how 3D map generated, data capturing, data post-processing, and data modeling is there. So data capturing, yes, you can capture either from aerial photography data, either from street level data imagery, point cloud. Okay, these all data in the capture, data processing will be there, and 3D map generated will be there. So data capturing include aerial survey and street level mobile mapping also. Potential location-based applications empowering all of use case on top. 3D indoor mapping. 3D indoor mapping, you can do smart mobility is there, new insight, location-based analytics, operating efficiencies, okay, better service quality. So these all in-house indoor maps, 3D indoor maps you can generate it. Yes, these are the technology basically. These are the technology: aerial photographs, satellite data, UAV data, building plans, airborne. Okay, airborne radar data, ground level data capturing, MMS, mobile mapping services, handheld GPS, terrestrial radar scanning. These all are there. So in 2020, Shanghai won the World Smart City Award with project aimed to make the city more reliable, sustainable economy. One of the most notable development in Shanghai is the development of the 3D geospatial model of the entire city. Shanghai Surveying and Mapping Institute has successfully implemented 3D GIS in urban planning. So definitely your geospatial technology will play an important role in smart city. So summary is what? Smart, sustainable, minimum energy, advanced technology, renewable, trusted, secured, geospatial data and infrastructure, that is included GIS, web maps, surveying, LIS, GPS, remote sensing. Hence, we won't build a smart city, we must invest on geospatial sector. Vision for smart city, smart green life, more convenient, more comfort, healthier, safe life. Make you a refined person, make India a developed nation. Thank you so much for your support, your good patience. Thank you so much.
Thank you, sir. Thank you very much. Participants, if you are having any kind of query, then you can ask. Okay, thank you, sir. It is totally a new concept.
Thank you.
Role of GIS in making a smart city, and I am very much thankful to you that you accepted our invitation in very short span and delivered your session here. And this I wanted to know our participant that Mr. Lokesh Tripathi is working on several projects with government also on urban planning and smart city. Thank you, sir. Thank you very much.
Thank you so much. Thank you.